A fan sent 3 metal samples, namely 20 CRMNTIH, 20 CRMOA, and 20 CRNIMO. 20 CRMNTIH is a common material for automotive gears. With excellent hardenability and impact resistance, it operates stably under high load conditions. 20 CRMOA is often used in pressure vessels and steam turbine components, and its high temperature strength and corrosion resistance are major advantages. 20 CRNIMO is commonly used in bearings and transmission parts, with excellent comprehensive mechanical properties that can cope with complex stress environments. Follow the camera to explore their mysteries. Cut the samples into small pieces. Place them into a metallographic mounting machine for embedding and fixing one by one. Use a metallographic grinder or polisher to grind the surface. Apply diamond suspension for polishing. After polishing, a mirror-like finish is achieved. Perform surface etching on them. Then start observing with a metallographic microscope. At 200x magnification, the alternating light and dark areas are the mixed morphology of metallographic structures such as ferrite and pearlite. Magnify to 500x. It can be found that the ferrite grains are relatively finer, and the lamellar structure of pearlite is more distinct. Differences in the morphology and size of the structure can be observed. These differences are matched with its need for good strength and toughness as a common automotive gear material. The structural state supports its impact resistance and wear resistance during transmission. At 200x magnification, the marks left by the hot rolling process are clearly visible, and the grains in the structure show a certain directionality. This is caused by the deformation and flow of metal during the hot rolling process. The distribution of ferrite and pearlite can be observed. Magnify to 500x. The grain boundaries are clearer. Fine precipitated phases that may exist in some areas can also be seen. The hot-rolled state endows it with unique structural characteristics. This enables it to adapt to high-temperature working conditions, such as pressure vessels and steam turbine components. At 200x magnification, the structure shows a specific mixed distribution. Compared with the previous two materials, differences in its structural morphology can be found. Ferrite, pearlite, and a small amount of bainite and other structures can be seen. Magnify to 500x. The boundary morphology of different structures can be distinguished more clearly, which helps judge whether its structure is normal in the as-received state. These structural details support it to cope with working conditions of heavy load and alternating stress. 20 CRMNTIH adapts to gears with its fine structure. 20 CRMOA resists high temperatures with its hot-rolled structure. 20 CRNIMO copes with heavy loads with its multi-phase structure. Composition and processing give each of their metallographic structures its own characteristics, which also determines that they excel in different industrial scenarios. What else do you want to know? Welcome to leave a comment in the comment section.